Okay, so we are going to be looking at the next element in our list, and that is going to be keys. So as we go down in our learning plan here, kind of breaks it down into the different sessions and the resources, the Excel spreadsheets, and the overviews that we've been doing. And down here in session number 4, we're going to look next at key design. So you'll notice here that I have a couple things that you can use if you so choose. I do have an Excel spreadsheet here if you want to download that. I'm going to download it right now and we'll be looking at it in a little bit. And then I also have some machineries handbook pages, but I also have a couple versions here in the classroom as well. So if you happen to not have a machineries handbook, then what you want to do is you don't necessarily have to purchase one, but it is a nice resource. And we have some that are here that you can use. And I did scan the copies of the pages, but they don't always come out great out of the machineries handbook only because the print is real small. The book is like, I'm not going to pull my pages out of this book. And so it's a little bit wavy. So if you need to use the books that are here in the lab, feel free to do so. Or if you can make out what's on these handouts, you can do that too. So let's first look at key design. So I'm going to go underneath my camera. Oh, I thought this was open. Give me just a second. I'll go underneath my camera and we're going to first start by looking at our layout. And I'm going to make this big. And you remember we kind of figured out that we're going to have our input coming in up on the top here. So this is our input. Then we're going to have our first reduction, which then goes to a jack shaft, which is in the middle here. Okay. And then it goes to a second reduction, which is going to be our output. Okay. Now this was my very generic layout for how we were going to be kind of getting the power, the rotational speed through our gearbox. You have taken the steps on picking out your initial gears for your first set of your first reduction, so pinion and gear, and then your second reduction, pinion and gear. And by choosing those, you now have some numbers in here that are going to be what your center distances are. And then you also would have drawn your gears to scale. Now, more than likely, you probably have hubs on one side of your gears, which is very typical. So if we look at, for instance, the Browning catalog, they have a hub on them. So they'll have a face width where the gears are. And that's really what I represented mine. Very simplistic, but through investigating and picking out your initial gears, you would have then the hub, and then you would have drawn your layout. So you would have had a hub on the front probably, and you would have drawn this to scale. Okay. So once we have this in place and we're to scale, then as you know, we went on to the next phase of doing your shaft design. We needed to have the gears first because we needed those forces, right? To see what needs to happen and what's generated at those points along the shaft to get the minimum shaft diameters. Then once you have your shaft diameters, you've got to go back and you've got to check these gears, and you've got to know, does my max bore accommodate what my minimum shaft diameter is? So if your minimum shaft diameter is larger than your max bore, you've got to pick new gears. Okay. That happens sometimes. It's just part of the design process. Sometimes we got to go back and forth before we, move forward. So once you have then your gears in place, then you'll probably revisit your layout. Okay. Because now if you did have to pick out new gears, these distances would have changed. Maybe your center distances changed a little bit. And then you would move on to bearings. Okay. And we talked about doing the overview of what's included for the bearings. So once we've gotten to this point and we've picked out our bearings, we have our shaft, we have our gears, now we're ready to design the keys. Okay. The keys are the element that is going to keep our gears at the same rotational speed and motion sunk, if you would, with our shafts. Okay. So in chapter 11, we looked, and I'm trying to remember what module it was. I think it was module 4 or 5, module 4, I think 4-ish, whatever, doesn't really matter, but we've looked at key design in our modules, and we looked at chapter 11. Now, I'm going to just go back to just showing us on this illustration on figure 11.1 down at the bottom here, this is a nice cutaway of a gear that's mounted on a shaft. And you'll right in here is where that key is. That key sits down in what we call a key seat, and half of it theoretically sits down in the key seat in the shaft. And then it extends up above into what we call a keyway in our gear. Okay, so it's interfering with both of them. So that way, when that shaft rotates, it like brings the gear along with it. Okay, all right. So the key is what we're designing now. The key is what we need to fit in between and make sure that there's, for instance, not too much slop. We want there to be a nice fit, a standard fit, so that when the key slides down in there, there might be a tiny little bit of wiggle room, but not much at all. If anything, maybe line to line contact, okay? Because we want, as that rotates, we don't want there to be much of a gap before it brings that gear along, right? Sometimes that's referred to as, well, it's a little bit of backlash in the key though, okay, not in the teeth. So we're going to be designing that key. All right. So you probably remember it hasn't been that long ago that we've looked at that, and we used the aid of a spreadsheet to help us along. So what I want to do is I want to pull up that spreadsheet and just kind of revisit exactly how we kind of walk through and the things that we want to look for and be aware of. So I am going to go back to our downloads, and I'm going to open up Excel. And I'm going to pull up, I know I put it in my downloads folder. It's up here. The file name is Gearbox Key Design All, because what I've done is I've incorporated all 4 keys on the same spreadsheet so that you don't have separate files for each one. So I'm going to enable editing on the top here. And you're going to notice as you go to the top, it has that same banner across like the Bearing design did. I kind of used that design for my start. This is going to be the key on the input shaft, and this is going to correspond to the first pinion, or the pinion in the first reduction. Okay. Then as we go down, the next section has 2 sections here. This is going to be the gear in the first reduction. And on the right-hand side, it's going to be the pinion in the second reduction. So the 2 just means second reduction. The 1's are first reduction. And then the last one is going to be gear 2, which is the gear in the second reduction. Now, each one of these sections works identically. Okay. So as we look up here, you're going to notice, I'll zoom in, the variables that we need to put in. So the first thing is going to be torque. Torque needs to be in units, in units of pound inches. Then we're going to put in our nominal shaft diameter. Okay. And that's going to be in inches. The nominal shaft diameter is the shaft diameter where you now have mounted the gear and you have, determined like, this is my shaft diameter. So this isn't minimum shaft diameter. This is what are we actually going to make it to, which you would have determined at the shaft design and lining it up with your gear and making sure that those 2 are going to work together. And then you would have decided on the fit. We talked about how to pick out that fit, the class of fit. And you would have applied that. So now the nominal size. So even if your limits of your shaft are to 4 decimal places, you have a nominal size. So for instance, if it's 1 inch, but even if the limits are 1.0016 and then down to 0.998, your nominal size is still 1 inch. And that's what you want to put in here. What is your nominal shaft size? Okay. Then you're going to determine the key based on that. Okay. So as we look here, my key is going to be a square key. I'm going to go to page 473 in the 6th edition or 425 in the 5th edition. And we're going to pick our key size based on that shaft diameter. Now, this is the very same chart that you will find in the machinery's handbook. This is not anything that the book made up. This is off of, standard sizes. And what we're going to do is we are going to find our shaft diameter, and we're going to find it between these 2 columns. It says over 0.3125 and 2 and including 0.4375. So if your shaft diameter nominally falls within that range, then you're going to go over to the right, and your key dimensions then are going to be a square key, height and width going to be that size right there. And you do that very same thing all the way down. Okay, then, once you get your nominal key size, then you need to determine what your, tolerances are. BJ, do you have your hand up?
Yeah.
We might have to look to a different resource then for you. We might have to. Yes, there are shafts that are smaller than that, but then you're really super tiny. So we'll have to talk about that and see if we can find a different resource. Okay. Yeah, because this is, I'll have to look, maybe the machinery's handbook. Hold on. No, it's down to 5/16. Yeah,
No, now that I think about it.
it will be okay.
Bearings are smaller than that, but my
Your gear
gear,
for, oh, okay. All right. Yeah. So you'll find your key size over here. Now this is nominal. All right. So for instance, I'm going to go to a nice number, a 1/4 inch. So if my shaft diameter is 1 inch, then a 1/4 inch is going to be the size, the square key that I'm going to use. Now that's just the nominal size. We need to make sure that this fits. You can't just draw a 1/4 inch key and then a 1/4 inch key seats and think everything's going to work, because remember, the title block tolerances are going to apply to any dimension on a drawing that doesn't have a dimension specified. So what we need to do is we need to make sure that the fit is appropriate. And that's where we use the machinery's handbook. It's already kind of figured out for us, which is nice. So, so what I'm going to do is I just want to show you, once you know that nominal size, you're going to put it into the key width. Now, you also need to know what the width, or I'm sorry, the length of your hub is, okay? The length of your hub is going to come from whatever gear you chose, okay? And now you need to put your key material in here. Your key material is going to be the weakest of the 3. Now, a good place to start, I think it was 1020 that was in there, or 1018 that was in the chapter, but you want to make sure that it's weakest of the 3 materials. Brandon. Yeah, through the gear, it's going to run all the way through the gear. But remember, you can't go outside of the hub, and I'm going to talk about that in just a second. Then you need to know the yield strength of your key material, okay? And then what it's going to do is it's going to calculate a minimum key length for you, all right? And it's going to be a funny number, but hopefully it's nice and short because it's going to be within the confines of your hub. After that, then you pick your key length. And this is where you have to, you know, look at your hub, but then also in relationship to the elements that are outside of the hub. So I'm going to go back underneath. And we looked at example 11.1 when we did this module. So you'll notice here that we have the side view of our shaft. And then this is where our gear is going to be. This one didn't happen to have a hub, but this is how wide we can deal with. Our key is on the inside here. And you'll notice that the key does not go outside the confines of our hub. And the reason that we have to make, we cannot, is because in this case, there is a retaining ring on either side. If we go and we cut into the retaining ring, we no longer can pick the larger of the 2 KT values. Now we have to add them together. So instead of 3, we would have to go 3 plus 1.5 or 1.6. I forget what it is, right? We would then have a 4.6 KT factor because you'd be taking out material here and causing more stress. Okay. So when you do your design, it cannot be outside the hub. So yes, the keyway is going to go all the way through. It's going to be broached all the way through, but you're going to be on the inside here. So if we look down at the top of this, there are going to be radiuses on the outside to accommodate the width of our shaft or width of our key. The key most often is going to be cut, you know, square on either end here. And those radiuses are going to be based on the tool that we're going to be plunging in to make that groove. Those grooves, those ends cannot be outside of the hub. They cannot be outside of the hub. Yes.
So I think what's, you know, is like, so you have like for the gears in the ground, you have the facelift.
Yep.
And you have the
Yep. Yep. So you have the whole hub. You have the whole, yep.
Okay.
Yep.
Right.
Yes. So Brandon's question was, you have the face width and then you have the hub. You have the entire length inside of here to get your key within and the radiuses. You don't have to just be by the flats or just by the hub because yes, that keyway is going to go all the way through. So if we have, let me see if I have a distance here. We would have a P and an F. So here, my dimensions for F on the top line are 1 1/4. Sorry. For F is 1 1/4 and P is 5/8. We add those two together for the total length through. Okay. Yeah. So you have that entire length. So that's usually never an issue. It's just designing your key so it's short enough. Because if I have 2 inches total from my hub, my key cannot be 2 inches. I look for that. Okay, I look for that. And that's why you have to put on there, we go back to our Excel spreadsheet, that's why you have to put your length of your hub in there, because that's something I check. Okay. So, so that's a little bit of calculating, maybe a little bit of layout work that you want to do to be sure that those radiuses, because I will look at that. So once you have your actual key length, then you're going to notice down here, it's going to tabulate some of that information, but there's some things to fill in. Now it's going to grab your nominal key width from up on top here, your nominal key height from up on top here, because it's a square key, and your length is going to come from where you determined what your actual length of your key is. But then you're going to be putting in your key seat limits and your key way limits. Key seat is where it's going to actually sit down in the shaft. Key way is where it's going to go through in the hub of your gear. Okay. Now to find these limits, these are what come out of the machinery's handbook. Our book did not address these. Okay. That's not in our book. So I want you to find it in the machinery's handbook. So again, we have 2 of them in the lab here, but I also have a couple pages scanned. They're not great quality. I apologize just because of the floppiness of the book. And then you're going to be putting these limits in here. Now, limits, remember, are when we look at the tolerances, what is its high value and what is its low value? All right. So let's look in the machinery's handbook here, how we find these. Now, different versions of the machinery handbook. I've got my personal version is the 28th edition. The one that we have here is a 23rd edition that's been floating around. Pages are going to be different in different editions. Okay, so just be aware of that, but they all have the same sections. They all have the same sections. So I'll go back underneath my camera here. Straight. And so I'm looking at the 28th edition and I'm in pages 2,385. Okay, this is where we have our keys and our key seats. The first on this page, the first chart that is here is the one where we pick our key size versus the shaft diameter. Same chart that's in our chapter 12. Chapter 12 is maybe just a little bit easier to read, okay, because it's bigger print and such. And they converted it to decimals as opposed to being in fractions, okay? So that's that chart first of all. Then I'm going to go a couple in, and then on page 2,389, these are going to be the standard fits for parallel and taper keys. These are parallel keys that we're designing for. Okay. So again, I'm going to try to zoom in here. This is small print. So on the left-hand side here, they're going to give us a column for over and including. And this is where you're going to find your key width. That's the first column. Then we're going to go over to the right, and this is going to be the width and the height. I'm sorry, just the width dimension or the width tolerance, just the width. Let's see. So now you're going to go over, here's our key width tolerance. Now this you don't have to worry about because it's based on standard key material. So when we specify a key, unless you're going with some, different type of material, there's key stock out there that we usually get that's going to be, to the dimensions we're expecting here. So it's a +0, -2. So it's ground, relatively accurate. And then to accommodate that, you are then going to add the following tolerances to your nominal size of, let's say, a 1/2 inch. You're going to add 0.002 for its top limit and you're gonna subtract 0 for its lower limit. So you would say 0.252 is my high value and 0.250 would be my low value. Those are the limits. Okay, the limits of the tolerance for the key way or the key seat. So now we look back to our Excel spreadsheet. That's what we would put in here for our key seat limits. And that's the width dimension. I'll add width in there because I thought I had that, but that's going to be our width. The height is going to be a little bit different because we're going to be getting our dimension from the bottom. Don't worry about the height because there's actually a lot of, there's almost a 32nd of an inch in some cases difference. It's not as critical, but the width is what's most critical. So you want to put that for the key seats and it would be the same number for the key way. And the reason I'm differentiating is because the key seat limits are going to be the ones that you put on the shaft. And you're going to go back to the shaft spreadsheet. There's a column that you created in your summary data that you're going to be putting your key seat limits. And then you're going to go to your gear. And there too, you have a column that you added as the requirements for the key way limits. And you're going to be adding those in there. Okay. We're not going to be doing any drawings. We're not going to be releasing these to production. If you wanted to create a layout using, parametric CAD, you can, but I'm not requiring it in here. Okay. I wish we had a little bit more time. If we had an extra week or two, I would, but I want you to get you to the point though, to have all of the items you would need to actually then sit down, model, and actually do the details. Okay. So these are critical things, fits that you have to be aware of. Okay. So these are going to go here, but they're also going to go on the shaft spreadsheet and on the gear spreadsheet. Now you're going to do this not only for your pinion one, but now you're going to go down on your jack shaft. You're going to do the very same thing for where your gear one is mounted and your pinion two is mounted. And then lastly, you're going to do it for your gear two. So again, in that second reduction. So 4 keys are what you need to design for. Any questions at all on this? I'm going to keep the machinery's handbook up here in the front of the room. You can use those while you're in the room. They can't go home with anybody. Okay. And then you're going to see back in the learning plan, I do have I think they're really kind of grainy and not great to look at, but I guess you can get by with them. These are the machinery handbook pages. This is the first one. And then the second one is of about the same quality. Okay. So that's there if that's more convenient for you. Any questions on those elements just yet? Okay. Let's go to the key design assignment. So you know exactly what you need to hand in and do to kind of round that out. So going down here, you're going to notice that there is in our gearbox design project, there's gearbox keys. These are worth 10 points. We click on that, it says you're going to design each key found in the design of your double rig gearbox. Here are your resources. So I put in here the Excel spreadsheet that we just looked at, and then those 2 machinery handbook pages if you want to use those. And then it says here, make sure to add the keyway and the key seat limits to the gear and the shaft design. Okay. And you're going to be, you know what, I need to clarify this. You're going to be uploading the spreadsheet file for me, because then I can see your values. You'll be filling out each one, which gives you all the details, and then you're uploading the Excel spreadsheet. Okay, I'll add that in here for clarification. So your deliverable, if you would be the filled in Excel spreadsheet. Okay. So questions on key design? Okay. Then what I'll do is I'll stop there and we'll start looking at locational elements.